Alright, in this video we're going to be talking about Big Idea 1, and basically what it is objects and systems have properties such as mass and charge. Systems may have internal structure. What's understood is that electric charge is a property of an object or system that affects its interaction with other objects or systems containing charge. And what you need to know that electric charge is always conserved, and the net charge of a system is equal to the sum of charges of all the charges in the system. An electrical current is the movement of charge through a conductor, and a circuit is a closed loop with electrical current. So in this video, I'm going to be going in depth about all of that. Give me a second here. So what you need to know that there is something called electric charge conservation, and it's a principle that electric charge can neither be created nor destroyed. So basically, if you take back to your 7th and 8th grade knowledge, energy is never can neither be created or destroyed. So the same thing happens in electricity. So say you have over here, you have 5 columns, which is the measurement for electricity for now, and let's say you have 3 over here. Now, if they rub off against each other, so just gonna draw some arrow marks. Arrow mark. They rub off against each other. The bigger ones becomes 4, and you're left with a question mark in the second one. Now, if you do 5 plus 3, you get 8 columns. Now, according to law of conservation of electricity, or law of charge conservation, whatever floats your boat, this has to equal 8c as well. So you have 4 plus a question mark, and now you know that this little sucker right here is equal to 4 columns. And that's basically demonstrating the law of conservation of electric charge. And yeah, that's about it. So there's another concept that you have to know, and it's called the electric charge conservation model. Yeah, the electric charge conservation model. And I'm gonna pull it up right now. So what you have here is you have a positive charge and you have a negative charge, and you see that these arrows are pulling towards each other, and the ones near the outside areas of the charge are being unaffected, but they're slightly curved. Well, you see these two, the ones near the middle, especially near the middle, are very close to each other, and they're almost as if they're pulling towards each other. And what this is basically saying is that if you have a magnet that's two sides, one positive, one negatively charged, if you put those two together, they will stick. Well, they will start to attract to each other. And if you do, say, a positive and a positive, or a negative and negative, and they will repel from each other. So if I had a picture of two positive electric charges, these arrows will be pushing away instead of pulling in. Hold up, give me a second here. And the last thing you need to know, another thing is that there's only 2 kinds of electric charge. There's only a positive and negative, and just like a proton and a neutron, yeah, a proton and an electron, you already know all of that. Last thing you need to know in the Big Idea 1 is the smallest observed unit of charge that can be isolated is the electron charge. It's also known as the elementary charge. Some quick facts: magnitude of elementary charge is equal to 1.6 to the negative 19th columns, which is really, really tiny. And if basically what you need to know is that if someone goes up to you and say that there's something smaller than the elementary charge, you can probably go and slap them on the face, because there's no such thing. The elementary charge is the smallest thing when it's isolated. Last thing, well, I already said last thing. Well, now the last thing you need to know in big idea 1 is that matter has a property called resistivity. And you need to, and basically that resistance, I'm just going to call it resistance. The resistance of a material depends on its molecular and atomic structure. Resistance also depends on temperature of a model. And what you need to know is how to differentiate a lot of conductors and resistors. Well, things that can resist well. So, heat and electricity conductors slash resistors are basically the same thing. Metal is always going to be a good conductor, and rubber will always be a good resistor. That's why in electricity you always see copper wiring, and outside of copper wiring you have rubber, so it can yeah, it can cover the copper wire so it doesn't expose them and sparks don't fly everywhere. Excuse me. And say if you had a problem, says there's a metal spoon and you have a rubber spoon, which would conduct more electricity. Obviously you would choose the metal one because, you know, metal's always really good. And that's about it for big idea 1. I will get with you on big idea 3.